This is Jenny Kunkel, and in this video we're going to take a look at concurrency problems. And the first concurrency problem that they're identifying is lost updates. This is when we have two or more transactions, they're all going out, reading the same data essentially at the same time, and then they're all kind of trying to make updates to the same pieces of data, which means that one of the transactions is going to win and have the last update, but we're going to lose some of the other updates that might have happened in between. So if we updated a particular column in a table in one transaction to be XYZ, but then the other transaction updated that same column to ABC, we're going to lose out on that XYZ because the later transaction is going to actually be able to handle that. And this is assuming that we're doing this all at the same time. So when we're trying to make updates simultaneously within transactions, these are when we're going to have some of these concurrency problems. If it's going to happen at different points in time, we don't have concurrency. It's just when we have things happening simultaneously and we have two transactions happening simultaneously, they're both trying to update the same piece of data. That's going to be the situation that we could potentially lose data updates. Then we have a dirty read, and this is essentially going to happen when a transaction reads data that has been modified by another transaction but not yet committed. So we have these two different transactions that are running. One's reading the data, the other has been updating the data, but it hasn't committed the data. It's going to be dirty because it hasn't been committed at that point. And this might be a temporary thing because what happens if that transaction finds that it's going to roll it back, and therefore that one transaction that read the data has data that's dirty that may or may not be valid because it may be committed at a later point in time or it may be rolled back. So that's dirty reads. Then we have non-repeatable reads. And this is going to occur when a transaction reads a row and then another transaction comes in and updates that row that we just read. And then the first transaction is going to try to reread that row for whatever reason, and it's going to get some type of a different value. And that's going to cause essentially an inconsistent analysis because we have this update that has been processed after we did the first read, and then within the same transaction, we're rereading the same data and we're getting different results back. Then our final is going to be when we have a phantom read, and that's when we have two transactions. One transaction is reading data, and then the other transaction is inserting a record after we read the data, and then that first transaction is trying to reread the same data, trying to reissue that same select, and now it's getting more data back than what it did in the first select because we have that extra inserted row that happened from that other transaction. So we have more data, and the queries are not providing identical results, and that can produce inconsistent or incorrect results. So those are the four types of concurrency problems that occur. Again, this is going to happen when transactions are happening simultaneously. We can set the transaction isolation level on a transaction. We can set it to read uncommitted, read committed, repeatable read, snapshot, and serializable in the database. And if we go back to our JDBC, we saw that we had transaction.repeatable read that we were adding. If we remove this, so let's go ahead and remove this and take a look at what options we have. So we have repeatable read, we have none, we have serializable, we have read committed, and read uncommitted from the JDBC programming option as well. So we have the ones that are available in the database that we can see here, which includes the snapshot, but then we also have most of the ones that are available on the actual programming side as well. Then if we go ahead and continue on, and we'll go ahead and set one of the isolation levels when we're going through an example here, trying to do a phantom read and then also a dirty read as well. We have certain ones that can be prevented if we set our isolation level to a certain level. So obviously, if we want to make sure that we don't have any issues whatsoever, we can go ahead and set it to serializable. There are other ramifications by setting it to serializable that we run into, because we have more of a chance of having transactions backing up, waiting for everything to finish for that serializable type transaction that's being processed. So that's going to certainly take care of our dirty reads, our lost updates, non-repeatable reads, and phantom reads, preventing them from happening. But then you might have deadlock happening because you have transactions backing up, waiting, and if they wait too long, then they're going to fail and deadlock. We also have snapshot that's going to prevent essentially dirty reads, lost updates, non-repeatable reads, and phantom reads. And then, of course, repeatable reads are going to be dirty reads, lost updates, non-repeatable reads. Then we have read committed, that's the dirty reads, and essentially that is the SQL Server default isolation level. So if we don't change it, it's going to be at read committed. And then, of course, we have read uncommitted, which is essentially none. And we're going to be setting ours to read uncommitted to actually try to get a few of these situations to occur. And we can also see that not only can we set the isolation level at the transaction level, we can set it at the database level, because we have a couple different alter conditions that we can use. And we can see that we're setting that read committed snapshot or allow snapshot isolation on as well. Now we're going to take a look at locking in the next video. We're going to go through a couple of examples for those concurrency problems that we saw, just to give you a little bit more context around those. We're going to try to simulate a dirty read, and to do that, we are going to be setting our isolation level at read uncommitted, which essentially should provide us with every possible opportunity that we can get, because it's not going to prevent any of the concurrency problems that we've already looked at. We're going to switch over to SQL Server, and within SQL Server, I have two different windows set up. I have one that I'm just doing a select statement against the DBO employees table and trying to retrieve the employee ID where it's equal to 1. And if we look at it right now, we should be able to see that we have the title of courtesy as MS dot. And what we want to do over here is we actually want to start a transaction. We want to update the data to Mrs. Then we're going to sit there and wait for 10 seconds before we roll back that transaction. So we want to start this first, and we're going to execute this. Then we're going to come over here and execute this. Now, one of the things to note is I have not gone ahead and set that transaction isolation to read uncommitted. So what happens is that this transaction is blocking this from going ahead and reading. It's going to wait until it's finished, and notice that we have the MS dot that is returned because it's waiting to execute the select until this is completed. Now, if I change this to be the set transaction isolation level read uncommitted, let's go ahead and execute that. Now if I go ahead and start this transaction again and go in here and run this, notice that it's coming back immediately. It's not waiting, not being blocked, and I'm getting that MRS dot being returned, which is dirty, because if I actually select it again, I should see that it is now back to the MS. So we got dirty data that was not valid. We were seeing it because we were running at read uncommitted, and it was MRS until we rolled it back. So that was a simulation of the dirty read. We're going to run through one more example, and in this case, we are going to do a phantom read, and we're going to modify our condition just a little bit. We want to go ahead and select from the employee territories where our employee ID is equal to 1. Then we're going to want to do a delay. So I'm going to copy that over, and we'll change that out. We're going to then reselect. and we should see that we have a different value. So we're going to go ahead here and change this to 0.5. Then over here, instead of doing an update, we're going to go ahead and do an insert into dbo.employee territories with our employee ID and our territory ID, passing in values of 1 and then also 01730. We're going to go ahead and wait for the delay of 10 and then roll back the transaction. So we're going to go ahead and start with this, and then over here execute this. And here we're seeing that in the first initial query we have 2 rows being returned. In the second query that we've executed, we're getting 3 rows being returned. So this gives you an idea of how some of those concurrency problems can occur. In the next video, we're going to take a look at locking.